Welcome back for Explain 4. In this problem we see that Arturo plans to make a deposit in one of accounts shown below in the table. To maximize his interest that the account earns, which account should he go through? So for account X, they're giving him this percentage, and then for compounding quarterly, so it's going to be more than once a year. Again, how many quarters earn $1? 4, right? Whereas Y is going to be something different. So let's calculate first the interest for account X. So for account X, the interest is compounded quarterly. So that means that the number of times that happens is 4 times a year. The rate is going to be 2.5, or as a decimal by dividing by 100. Go ahead and work that out. And that would be 0.025. The next thing we're going to do is in our equation, so it says use the formula for the rate. We're going to write in 1 plus the rate, which was about 0.025 divided by 4 to the 4th power, since n is 4, minus 4, or minus 1, sorry, minus 1. So on our graphing calculator, or our Desmos calculator, desmos.com, we're going to use our scientific calculator to kind of calculate this out. So let's do that. So opening up desmos.com, you see that we have a scientific calculator, so not the graphing one, but the scientific one. We're going to go ahead and put in parentheses 1 plus fraction 0.025 over 4. Close the parentheses. We're going to put to the 4th power minus 1. Alright, and that yields about an interest of 0.025. That's my effective rate. So we're going to go, that would be about 0.02523. Okay, let's go ahead and figure out the next one, which is for our Y value, that's our interest rate, 2.48, which will change into a decimal in a moment, and it's compounded monthly. And how many months are in a year? That would be about 12, right? So go ahead and calculate 2.48 divided by 100, and that would be 0.0248. Let's go ahead and now plug in those values here. So that'd be 1 plus our rate, which is 0.0248, divided by 12 to the 12th power, take away 1. So let's go ahead and use our graphing, or not our graphing calculator, but our Desmos scientific calculator. Okay, parentheses 1 plus fraction 0.0248 divided by 12. Close my parentheses to the 12th power minus 1, which is about 0.0250. So let's go ahead and record that on our piece of paper. And that would be about 0.02508 for the effective rate for our Y account. So just like it shows here, whereas X had an account of 0.02523 and Y had one of a different amount. Now this is in decimal form, so what we could do is to change it to a percentage. We can multiply both by 100. So take some time to do that right now. That would be about 2.523%. Whereas this one would be about 2.508%. So comparing these two and filling out our sentence starter, that would be that percent there, and that would be this percent for the Y value, or the Y account, I should say. So that means comparing these two, it essentially looks like, even though they seem pretty similar, I think account X is probably a little bit larger than, and this person, Arturo, should choose account X if he's going for the greater interest. So let's try part B. So for B, it says Harriet plans to make a deposit into two accounts. Account A is going to yield about that much nominal rate interest compounded continuously, whereas for account B, that's going to be 3.25 compounded semi-annually. Okay, so let's go ahead and find out for account A. So this interest is going to be compounded continuously. Power the natural number E, and that rate would be about 3.24, which we can change into a decimal by dividing by 100. So that would be 0.0324. So our rate would be about 0.0324. And we're going to go ahead and figure out what this would be. Go ahead and use, again, our Desmos calculator to work that out. And let's go ahead and use our Desmos calculator to figure out E to the 0.0324 power, take away 1, which is about 0.03293. Okay, so we're going to record that on our paper here. So that was about 0.03293. So for the second account, account B, the nominal rate is about 3.25, which will change into a decimal momentarily. And you'll see that it's compounded semi-annually. Since it's semi-annually, that means it's going to be twice a year. So our end value is going to be 2. If you haven't already done so, go ahead and divide 3.25 divided by 100, and you should have gotten 0.0325. So let's go ahead and put in our R value, our N value, and let's go ahead and use our Desmos calculator to figure out what that would be for account B. Alright, so let's go ahead and put in parentheses 1 plus fraction 0.0325 over 2, close that parentheses, raise it to the second power, we're going to subtract 1. And that would be about 0.3276, so let's go ahead and record that as well. So that would be about 0.03276 for our B value, or B account. So here our annual rate effectiveness was for A and B. For A was 0.03293, and for the B value was, or for the B account, that was 0.03276. We can change each of these into a percent by multiplying by 100. So let's go ahead and take some time to do that for account A and for account B. And that should yield about 3.293%, whereas B would be 3.276%. So that means even though they're not that far off, it looks like account A, again, has a greater effective rate. So the person, Harriet, should choose account A. So take some time, pause here, and do the explain for problem found in your packet.